Okay, good morning everyone and welcome back na with our discussion. So welcome back to our channel na. Okay, so we will be discussing a homogeneous differential equation. No, so we already know on how to classify a DA being a homogeneous, no, by checking its homogeneity. And in order to solve, we are given some steps, no, in solving a DA classified as homogeneous differential equation. So first is the checking of its homogeneity. Now after knowing that the DA is homogeneous, then you have to look for the coefficient of the differential. So if the coefficient of the dy is simpler than the coefficient of the dx, so start your transformation replacing your y with a product of vx. And the dy can be equal to v dx plus x dv. If the coefficient of the dx is simpler, so it is the x variable which will be transformed. And the dx will be replaced with v dy plus y dv, which is a differential of the product of the vy. Now, simplify the equation and solve the equation as a VSDA. So usually when you transform your variable now, when you transform your equation, then you will always arrive with a DA, which is a variable separable DA. That is why instead of solving for a homogeneous, so when you transform, so you will be solving for a VSDA. Okay? Then you can restore the variable now by substituting back now on what is the equivalent to your V, because your V will actually appear in step number 3 being part of your solution. So, for your final answer, it should be expressed using the original variable. Okay? Now, when we are given a problem like this, now, the homogeneous differential equation, so this is only a second method of solving a differential equation, and our ultimate goal here is really to arrive with a DA which is a variable separable DA. So do not forget that when we are given a differential equation, so there is also a possibility that this is a VSDA. So always start by checking this as a VSDA before you proceed with treating it being a homogeneous differential equation. So when you check your first term, now we cannot separate factors which is purely y and a purely x factor. Now, so try. If you remove your y here being common, so the other factor will still contain x plus y. So it's not purely x or purely y, no? So that means this cannot be a VSD. So if not, then I have to check for the homogeneity. Now, the coefficient of my dx and dy are all polynomial. It's easy to determine the homogeneity of this, no? Because you have to check only the degree. If the degree of every term involved in the coefficients are the same, then the D is classified to be homogeneous. No? So, checking, this is in the degree of 2, this is in the degree of 2. Okay, so this is homogeneous coefficient of the dx, but it must also be compared with the other coefficient. No? So, dapat this will also be in a degree of 2. And this is in a degree of 2, meaning this is homogeneous coefficients, no? Or the DE has homogeneous coefficients of the same degree. Okay? So, you can now look for the coefficient, no, of the two differentials. The dx has a coefficient which is composed of two terms. Okay? While the dy has a coefficient which is composed only of a single term. So the simplicity of the coefficient will depend on the number of terms involved. No? Now, if the coefficient of the dy is simpler, then transformation starts by replacing your y with a vx, and your dy will be replaced with a v dx plus x dv, which is the differential of the product of vx. Now, okay. So, in the second term, if this is replaced with two terms, and then you will only be distributing a single expression, then that would be easier to work with. But try to imagine if you are replacing the dx with two terms also, then you will be multiplying a binomial with another two terms expression, then that will make your work a little bit complicated. Okay, so that is why we need to look for the simpler coefficient of the two differentials. Okay, so proceed. Now, substituting, replacing your y with vx, no? So we have v with y, so that is why we have x times the vx, then plus the y squared. Okay, this is vx. Okay, so this is now the coefficient of the dx free from y. Minus x squared, And then the dy is now equivalent to the v dx plus x dv. Now, I notice that there is an x squared here. There is also an x squared there. There's also an x squared here as a factor. So, I may remove my x squared, no? So, I can apply factoring to simplify this before I perform the operations of the terms, no? I am removing the x squared from my first term. So, what is left is v plus the v squared, correct? Okay. And then, what else? So, if I'm going to divide with x squared, no, so the x squared will not be part anymore of the distribution. Okay, so this is now the resulting equation. I have the v dx, no, so it's only v dx substituted to v and the v squared. Okay, so it's now free from the x squared. Dire, I have v dx negative minus x, 1x now because this is out, so minus x dv. So, dili x cube, I mean. So, x cube is already removed. So, what is left is the minus x dv. Now, notice that we have terms which are exactly opposite of the other. So, this is excluded already, or this is eliminated. These two are eliminated, no? So, v squared dx and x dv resulting an equation which is a variable separable. So, I can apply variable separation, okay, dx together with x and dv with a v squared. Okay, so what is the result? So, I have dx over x, okay, and we have a dv over the v squared. But in order to arrive with an integrable term, no problem with my first term because that takes a d over u form, kini under a power rule, no? So, you can have your v to contain a power of minus 2 dv before I can use the power rule of integration. First term is already ln x. Minus, increase the exponent by 1. It's minus 1. This is the n plus 1 also. And that's equal to c. That's equivalent to ln x plus, this is plus already, then 1 over v to change the power to positive. And that's equal to c. This is a general solution, but this is containing, so, na-repeat, no? So, step number 3, no? So, this is containing a dummy variable v. So, that is why I can restore the variable y, knowing that my y was changed to v dx. So, my x now can be y over, my v can be y over x. No? So, I can substitute ln x with 1 over v. My v is y over x, and that's equal to c. So, it's the reciprocal of y over x. That is x over y in my second term. No? So, ln x plus x over y equal to c. But take note, there is a condition given. So, that means if there's a condition given, then you are not going to stop with a general solution. You have to go with a particular solution by first solving for c. Okay? So, finding the value of c with the conditions given that if your x is equal to 1, y is also equal to 1. Or, it means that the curve passes through point with coordinates of 1 and 1. So, ln of 1, correct? This is 1 over 1. Na? So, ln of 1 plus 1 equal to c. But what is ln of 1? ln of 1 is 0. Na? So, that means, if that is 0, then 1 over 1 is 1. So, your c is equal to 1. Then, I can go back to my general solution, and this time, I'll be replacing my c with what is being evaluated, and that is equal to 1. Okay, so here I have ln x plus the x over y, and that's equal to 1. If I'm going to separate the x over y, actually simplification na lang ni daring part na. So this is already an answer if there is no required form. Okay? But in order to be exposed also with simplification process when they are needed, okay, so we have this. X over y is equal to 1 minus ln x. Now, if this is a 1, a term which is equal to 1, then the ln of e also has a value of 1. So, I put them in terms of a logarithmic term or a natural logarithm so that I can further combine them, taking a ratio also as a difference, no? Because kini ratio mo dyan x over y. So, if this is ln of 1, ln e, which is equal to 1, then ln e minus ln x as a difference of two logarithmic terms, then I can also write it as ln e over x. Okay, so that looks almost similar with the left. Okay, so you can have this as your answer. If you want to remove the ln, so what are you going to do? Take an exponential both sides. Anyway, so okay na niya. So maybe you need more example. Okay, so here is another problem which also requires us to arrive with a particular solution because of a condition given. Okay? Now, this is not given in a general form of a first order first degree. So, I can maybe rewrite it now starting with a dx term followed with a dy term equated to 0. That's equivalent to, okay, so what are the terms in my equation? Okay, so the numerator of my fraction here, y minus the square root of x squared plus y squared is multiplied with a dx. That's equal to x dy. Okay, and if I'm going to transpose my x dy together with a dx term, so I have a term which is minus x dy equated to 0. How about the degree of my term here? This is 1. This is also 1. Can this also be 1? Yes, because if I'm going to replace with k squared ba, na? And x and y, or k and x, kx and x and ky with y, so obviously doon na k squared as a factor. The square root of k squared is equal to k with power 1. So that is why, so this is also homogeneous, no, of the same degree 1, no? So I'm going to consider the coefficient of the dx and dy. Obviously, ang dy is the one containing the simpler coefficient, no? So I have to transform my dy, no, or my y, okay, replacing that with vx, okay? Then the dy can be a product of v dx plus x dv. But actually, no, if you're going to make another option of changing your x as vy, no, actually, it does not make your answer wrong. Only, your solution can be very lengthy compared to having this. No? Okay, you will be multiplying two terms expression with radical, no? So it's not good to start with x. Okay? So you can start with y because your y is the one that contains a simpler coefficient. Ayaw og sugod sa x dire, bahala na ganahan kag x, no? Okay, so just reserve that for other purpose. Okay, now, in transforming your equation, replacing y with, here is a y, purely y term. This is now vx. Okay, so square root of x squared. So this is v squared x squared because that is a product of vx, correct? That one. And then minus x, the dy is v dx, according to this, plus x dv equal to 0. Actually, there is a common factor here which is x, pero ang atong x dire medyo na priso pa man, no? So I have to distribute na lang directly. So vx, okay, with dx, and this expression, okay, can also be distributed there. Okay, but ang ibuhat diha, no? So ato nang i-factor out ang x squared, no, before the distribution, no? Then removing your x squared, so we have a quantity 1 then plus v squared dx. Okay? Then it is distributed, no? Okay, pag distribute, we have vx dx. This is x na lang, no? Taking the square root of x squared is x, then the square root of 1 plus the v squared. So multiplied also with the dx. This is minus v x dx. Okay? Coefficient ado sa alphabetical para we can easily identify terms which are similar. Okay? So minus x squared dv. And again, I notice that my first and third term are opposite. So this can be eliminated. And we notice also that the terms left are this, x and the square root of 1 plus v squared minus x squared. So this is already a variable separable d. So if this is a differential in x, no? So kinesia is not supposed to be here because this is purely y. And that is why I have to remove this by dividing with the expression the square root of 1 plus v squared. They are all negative, so I just include the negative to convert this as all positive term. X squared here is also not needed. Now, because this is v. Okay, so I can divide with x squared. Okay, so this is now the resulting differential equation after separating your variable. Dx over x plus the dy over the square root of 1 plus v squared equal to 0. So, after separating your variable, so pwede na ka mag-integrate every term of your equation. Pero what is the formula applicable when you do the integration? The integral of dx over x plus the integral of this is equal to 0. I think the first term looks very familiar to us, no? So that will give us an integral which is ln x, correct? Kine, maybe I can recall a formula, no? An integration like this. But if in case, no, you are able to forget the formula applicable for this, no? So you can also recall a method of integration, no? If your integrand contains a form of a squared plus u squared, then you can recall a method of integration which is a trigo substitution. But since there is a formula for this, no? So I may go with a formula which is this one. The integral of a du over the square root of u squared, or either plus or minus a squared. So that can be ln of u plus the square root of u squared plus or minus a squared. This is now taking a form of u squared plus a squared. Now, so what would be your u? My u is v and my du is dv. So that means I can apply the formula directly. First term is ln x plus ln u, which is v, plus, I copy the function, that's plus, so plus akong gigamit, okay, that's equal to c. They are all logarithmic terms. They are they are operated with addition, so I can combine them as one by taking the ln x times this expression. At the same time, I have to restore my variable. So I have ln x, okay? ln x, this is my v, which is y over x, correct? Okay, plus the square root of 1 plus, this is your v squared, no? So we have y over x also in square. And combining them with the denominator of x squared, so this is x squared plus y squared, no? Then, actually, I can distribute my x, but I have to simplify this first. Then I can separate the square root of my numerator, considering that my denominator is a perfect square. So the square root of the x squared is x. So the same with this, also have the same denominator of x. So that is why when I'm going to distribute my x over the terms, no? So this will produce only y. When this is also distributed here, only the numerator is left because x over x is out. So the second term is the square root of x squared plus y squared, and that's equal to c. Now usually, if this is composed only of two terms and one is logarithmic and the other is constant, no? Usually, it is converted into an algebraic form by taking, no, an exponential both sides of my equation. So the exponential of ln u, di ba, is actually u. So the exponential of ln, considering this as your u, is y plus this expression. The exponential c remains to be an arbitrary. That's why I'm free to call this as the same c. Okay, so this is now my result. So y for this plus the square root of x squared plus y squared equal to c. This is a particular solution. And there is a condition given to find our c value, that if your x is equal to square root of 3, y is equal to 1. So I have to substitute this being 1, then plus 3, yeah? Being the square root of 3, then plus 1, that's equal to c. So what is the c value? C is equal to pila? 1 plus 2, so that's equal to 3. This is 2 added to 1, so we obtain 3. Then particular solution can be y plus the square root of x squared plus y squared, and that's equal to 3. But what if I'm going to bring my y together with 3? So simplifying further, no? Can you think of another possible approach to have this looks more simplified than this one? This is involving radical. What if I'm going to take the square both sides, no? Considering that there is only one radical term, no? So taking the square both sides, okay? We also have a binomial square. So, taking the square both sides. Okay. So, there we have the radicand left. And I have the expanded form of my binomial. So, if you have 3 minus y, you put that into square, you arrive with PST. What's PST? A perfect square trinomial. Okay? Square. Twice their product. That is the minus 6y and then y squared. So, this is a perfect square trinomial. Y squared is common. So, x squared is left here. Then, 9 minus 6y. So, this is now your answer. If you have to look at this, it looks very far from the previous answer. So, even if it is a multiple choice type of exam, and one of the choices is this one, so, posibleng hindi na mo pilion, labi na og ang imong paagi pag-identify sa answer, imo lang taghap-taghapon, no? So, we should know on how to simplify, no? So, if you will be asked, what kind of curve is our particular or our solution? Actually, this represents a parabola. Ilhanan sa parabola, only one variable is in second degree, the other variable is in first degree. Okay? One last problem. Okay. Usually, in the first and second example, we write our equation to follow a general form, meaning m dx plus n dy form. Okay? But this one, I have a dy term, then there dy and the dx term. So, writing the equation to follow the general form, you have to check for the homogeneity and pagkahuman, imuhan tanawon whether which coefficient is simpler. Okay? Now, I'm not going to reduce my equation anymore to a first general form of a first order first degree DE, but I have to inspect the homogeneity by just looking on the degree here. This is 2. Is it possible to have a degree to here? Yes, that's x squared. That is xy, so it's over a degree of 2. This is a degree of 0. So, every term has a degree of 2. No? So, meaning it is homogeneous of second degree. Now, which coefficient is simpler? If this is a dy term, there's another dy term. But I only have one dx term. That would mean that the dx is the one having the simpler coefficient. Okay? Without reducing to m dx plus n dy form, by inspection, I know that that is homogeneous differential equation. Okay? And the coefficient of the dx is simpler. So, if the coefficient of the dx is simpler, then start reducing your x or replacing your x with vy. V is also a ratio of x over y. And it's good because this ratio is x over y, wherein later this can also be replaced with v. Okay, now I have to substitute. Transform by substitution. Okay, y squared dy. It's x that will be changed. This is x. Okay? So, this is x squared, correct? That is x squared dy. X squared is now v squared y squared. So, this is actually produced by distribution. Including this is distributed. That is why there is an exponential of v. Okay? So, distribute at the same time substitute. Okay, this one. This is xy, exponential x over y. So, x becomes vy. Y remains the same. Exponential v. The dx is v dy plus y dv. Okay, perform the operation completely. I have y squared dy minus v squared y squared exponential v dy. How about this one? This is v squared. Now, when that is distributed, v squared, y squared, exponential v, minus, v, y cube, di ba? This is y squared, and y cube. Then, we have what's that? Exponential v with a dv. Now, again, I notice that these two terms are opposite, meaning I can eliminate them. What is left is the y squared dy and minus, when it is transposed, is v y cube exponential v dv equated to 0. And after transforming your equation using a dummy variable v, then you will always arrive with a DE which is a V is DE. So is it true with the resulting equation here? This is y dy. Okay. So this is V. But there is y that is left. No? So I can remove my y cube by dividing with y cube. V and exponential V. So they are in place because this is V term. Okay? So dividing with y cube and proceed with integration. If you divide this with y cube, no, so y squared is out, there is still y that is left. You'll always arrive with dy over y or a dx over x as part of your differential of your terms, no? Before you proceed with integration. Okay, so we have this. We have dy over y plus, okay, v exponential with dv. So you do the integration after you separate the variable, no? First term, that's L in y. Kine, what formula of integration is in your mind? This is a product of two different functions. No? So maybe you can recall the IBP or the integration by parts. No? Where you have to consider U and a DV part. Okay? So, applying your integration by parts, this is the formula. So there is U and DV part. So that the first term is UV. So meaning your U, your DV will be subject for integration. Okay? And you have the integral of V du. Okay? Just follow this one. If my U is V, okay, and my dV is the exponential V dV, okay, du is the dV. Integrate both sides, I have V, which is an exponential V. Following the formula, okay, we have V exponential V, then integral of a product of exponential V dV. Following this form, na? Kana, paingon dito. Okay, so this we have L in y plus this is V dV negative because of this formula, so minus integral of V dV equal to C. So there is still a process of integration in the last term here. So you can complete by doing the integration. Okay, this already follow a formula exponential u du. Okay, so this is the complete integration process, no? L in y plus V exponential V minus. This is exponential V equal to C. Now, I want to combine the L in y together with C. If I'm going to take the ln of C, di ba that is still an arbitrary? So, the C term here, pwede na ko himuon nga ln C. So, I combine my ln C with the ln y for possible simplification. Okay, so this is transpose. These terms are also taken to the right, no? So, taking to the right, this one. So, this is exponential V minus, this term. And then, I can restore my variable. No? So, this is, after factoring out my exponential V here, and replacing your V with x over y, then I have 1 minus V, and V is x over y. Now, these terms here, one is fractional, na? Combining them as one, take the LCD. So, this is y minus x, correct? So, with y denominator as y. Okay? So, simplifying further, multiplying with y. So, I have my y associated with my ln of y over c. So, the right side is the exponential of x over y, which is equal, multiplied with y minus x. Sir, nagkaluyam lagi ka, sir. Hapit na mahuman. Okay? So, subscribe. Subscribe. Okay lang kung di, no? Pero mas malipay kung subscribe ka, no? Bitaw. Thank you for watching and have a good day. No? So, bitaw, no? Malipay kung mag-subscribe mo, no? Kaya mura mo na atong kalipay na rin mga kita. Na-present mo dahil sa akong mga audience, akong gibuhat dire, no? So, I hope, no, kung naamoy mga amigo, no, diha nga nanginhanglan ini, bisag wa manginhanglan, ipashare lang nila, no? Okay, posible sila doon na yung mga amigo nga nanginhanglan ini, no? So, kani ato gibuhat, dili ra ni para nato, no? So, pwede ni makatabang sa uban kon dili mo magpanagana o share ini, no? I know nga this is very useful, no? So, mga nanginhanglan ron ining panahon na. Okay, so I hope to see more subscriptions and viewers also, no? So, thank you for watching and encouraging me to do this kind of work for you. Okay, so bye-bye.